Okay, so stopping distance. So it's not too much of a hard topic to get you to get you basic understanding of it. Essentially, if you've got a car or anything really traveling along um, at whatever speed, and there's some hazard in the way that they need to avoid, then there's going to be a certain, let's say he's just seen it. Oh, he's seen there's a hazard, needs to now come to a stop. Now, he's not going to come to stop instantaneously. He's going to travel a certain distance before he finally comes to a stop, hopefully in time to miss hitting the person. So this entire distance we can call the stopping distance. Okay, now if we actually think to ourselves, what is the stopping distance down to? Like, what is it? What is it affected by? So have a little think about what things would the stopping distance be affected by in this. So basically, this stopping distance gets broken down into two distances, and one of the distances is well. Okay, let me first think about what are the things that would cause it to stop. Well, let's say it was a really icy road, then he puts on his brakes, but he carries on sliding, or maybe his brakes aren't very good on his car, or maybe the wheels aren't very good, or maybe it's loose gravel or something like that. Now that is providing he's already applied his brakes, but then there's another distance before that. So this is where he puts his brakes on, and that distance that is totally down to the road, the car, the tires, whatever else. This is called the braking distance. He is now braking, the braking distance. But before, and at that point, that is where he braked. Before of that, he had to react to it. So so at that point, he wasn't slowing down at all. If he's going at 30 miles per hour at that point, he's also going 30 miles per hour this entire distance. And this distance here is called the thinking distance. So thinking distance, I'm just going to say. So in other words, the stopping distance is equal to the thinking distance, I'm just going to call TD, plus the braking distance. So that's the easy bit. So which is mostly, we say, oh, right, yeah, it's just down to thinking distance. I've got to think for a bit, then I put my brakes on, then I'll come to a stop. Then they will say, what is it that affects the thinking distance? What is it that affects the braking distance? So thinking distance is affected by, are you tired? Have you been drinking? Are you distracted? Things like that. And then braking distance is down to everything else. So this is the driver. And this is the car and the road, etc., etc. Okay. Now, the next thing that bit's still fairly easy, but then it gets a tiny bit harder, and you want to be starting to think about how is the motion of the car changing over that time between, if we say that's t equals 0 at the beginning, then and then that t equals whatever at the end. What is happening to the motion of the car? So so if we draw another graph here, and that's t, and that's v, the changing velocity over time. Now, what happens at first? He's traveling at that speed, and he continues to travel at that speed for a while, and then he's seen it. By the way, it's not like he hasn't seen it yet. He has seen it right at the beginning, but he hasn't reacted to it yet because maybe he's tired, and also, well, even if he's in perfect condition, you still don't have, it takes a little bit of time, a short amount of time to react. So at this point here, so we draw a dotted line, this point here, he's now reacted. He's seen it and he's reacted. Okay. So, and now the car slows down. Or if we assume that the car slows down at a constant rate, then we give that a straight line. And then the deceleration we can work out by the gradient. Obviously, that bit has no deceleration because it's working at constant speed. And we can work at the total stopping distance by using this graph. So the thinking distance, this is TD. This is the thinking distance here. Whoops. TD is just going to be, let's say this duration of time, we can call his TR, reaction time. Okay, so the thinking distance TD is equal to V multiplied by his reaction time TR, and then his this bit here, this distance here, this is going to be his braking distance, which is again a triangle, is going to be equal to half multiplied by, and what can we call this? Well, I suppose we can call it the braking time. There's probably a more useful thing that we could do, but let's just for now call it a braking time. And that's going to be half times V times TB. You could go further and talk about what rearrange that in terms of the acceleration, then find out the acceleration in terms of the force of the brakes, and it could get more and more advanced. But we won't go too crazy about this. So, but you can see how you could make this more advanced at that point. It may not get that any as advanced. That it certainly won't get any more advanced, I don't think. The main thing you need to know is the simple bit here, and then if you want to go a bit more advanced, you can think about it in that terms.